All right, today we're jumping into something that completely flips the script on how planets are born. We're talking about a discovery that rewrites the rulebook on where life itself could get a foothold. So yeah, let's dive right in. It's one of those huge questions, right? Where do planets like ours even come from? And for a really long time, scientists thought they had a solid, pretty straightforward answer. The old thinking was that you needed a cosmic nursery to be, well, quiet, peaceful. Think gentle clouds of gas and dust, just slowly coming together over millions and millions of years. That's how we thought our own solar system got its start. But what if that's not the whole story? What if the complete opposite is true, too? What if the most violent, chaotic, radiation-blasted places in the entire galaxy can also cook up new planets? That's what we're getting into today. Okay, so let's set the stage here. To really get why this is such a big deal, you have to understand that for decades, certain parts of space were basically considered forbidden zones for planets. I mean, scientists saw them as total dead ends, no chance of forming worlds there. And here's why. The old argument, like the one from Konstantin Getman at Penn State, was pretty simple. You have these giant, hot stars blasting out insane amounts of UV radiation. The thinking was that this radiation would it would blow away all the raw materials, the gas and dust that you need to build a planet. It's like trying to build a sandcastle in a hurricane. So you've got these two totally different pictures. On one hand, you have the calm, peaceful nursery we thought was the only way. And on the other, you've got this cosmic war zone just flooded with destructive energy. It seemed absolutely impossible for a tiny, fragile baby solar system to even stand a chance in a place like that. But, that's what science is all about, right? It's about questioning what we think we know. And to do that, to really push the boundaries, you need a brand new tool, a whole new way of looking at the universe. And that's where the hero of our story comes in, the James Webb Space Telescope. The thing about JWST, its superpower, is that it sees in infrared light. And what that means is it can slice right through all the cosmic dust and the intense glare that basically blinded every other telescope before it. For the first time, we could look straight into the heart of these super violent, chaotic places. And this is crucial. As astronomer Maria Claudia Ramirez Tanis says, there was literally no other machine on or off Earth that could do this. JWST is the only one with the power to spot these faint little disks so far away. Without it, these potential planet factories would have just stayed hidden, totally invisible to us. So, okay, we've got this amazing new eye on the universe. What do you do with it? Well, a team of astronomers decided to point it at one of the most extreme, intense environments they could possibly find, a real cosmic crucible. Their target was something called XUE1. Now, this isn't just some random cloud of gas. It's what's called a protoplanetary disk, which is basically a planet factory. It's a swirling ring of raw materials orbiting a young star. And the catch? It's in a really, really bad neighborhood. So just how bad is this neighborhood? Get this. XUE1 is getting hit with 100,000 times, that's 100,000, more UV radiation than our solar system ever had to deal with when it was forming. The lead author on the study, Byron Portilla Ravello, put it in a really great way. He said, if you could somehow pick up XUE1 and drop it right where our sun is, in our quiet little corner of the galaxy, it would get 100,000 times less UV energy than it's soaking up right now. That's just mind-bogglingly intense. So that's the big mystery, right? How on earth could anything survive that, let alone build a whole planet? To figure it out, the team took all that amazing data from the JWST and fed it into a super sophisticated computer model. The way they did it was really clever. First, JWST stares at the disk 5,500 light-years away and gathers all this data from its light. Then they use that data to build a digital twin of the disk in a computer. And here's the cool part. They kept tweaking their computer model until it perfectly matched what JWST was actually seeing in space. Once it matched, they knew their model was right, and they could finally see what was really going on inside. So, what did the model show? Well, first it confirmed what everyone already suspected, that brutal UV radiation was absolutely hammering the outer parts of the disk, just blasting it, heating it up, and changing its whole chemical makeup. And this is the incredible twist. The model showed something else. The outer part of the disk, the part getting blasted, was so dense that it was actually acting like a shield. It was protecting the inner part of the disk from all that radiation. And guess what forms in that sheltered inner zone? Rocky, Earth-like planets. It's like the disk brought its own umbrella to the storm. And it gets even better. Inside that safe zone, tucked away behind the shield, the models showed more than just dust. It showed water, H2O, one of the absolute key ingredients for life as we know it. It was just sitting there, safe and sound, in one of the most violent places we've ever looked. So you can imagine, a discovery like this has some huge implications. It fundamentally changes the map of where we should be looking for other worlds, maybe even habitable ones. The big takeaway here is just, wow. Building a planet isn't this super delicate, fragile process we always imagined. It's tough, it's resilient. It can happen in places and under conditions that we used to think were completely 100% impossible. So, what does this all mean for the future? Well, for one, it blows the doors wide open on where we can look for exoplanets. It tells us that even stars born inside those crazy, chaotic, jam-packed star clusters could have planets. And that means our galaxy could be way, way more crowded with worlds than we ever dreamed. And that leaves us with a final, pretty thrilling question to chew on. If the stuff that makes planets, and even the ingredients for life, can survive in a cosmic hurricane like this one, what other forbidden zones have we been ignoring this whole time? And where else, in the most unlikely corners of the universe, could another Earth be waiting to be discovered?